Hey, honors physics students, here are some hints for the Chapter 4 textbook assignment. It's going to go kind of quickly, so feel free to push pause if you want to write things down. Let's start with number 64. I would suggest that you simply use, for number 64, simply use the weight formula, which is just m times g. Remember, the mass is different than the weight. So you multiply mass by the acceleration of gravity, or the gravitational constant, 9.8 meter per second squared. Let's jump over to number 68. Here I suggest you use chapter 2 and 3 formulas. Have that sheet handy for you all the time. It's really useful. Then you write the knowns and the unknowns. Of course, it starts from rest, so V1 equals 0. Then it will have a V2 of 26.3 meters per second. The time is 0.59 seconds. And the most important thing is to write the A equals question mark. So find the formula that has those, solve for A. Part B, why not use the most important formula for the chapter, net force equals ma. There is that hint. Let's jump over to number 73. Okay, number 73. First, let's again use the chapter 2 and 3 formulas. Again, for number 73, the V1 will start as 0. And you will have an acceleration, they don't list it, but you know when something drops, 9.8 meter per second squared for the acceleration. So that should be helpful for you. Well, let's look at part B. Part B is a completely new question. Here, the old V2 becomes the new V1 of a time of deceleration. So again, write the knowns and unknowns, but start them all over. This time we're going to write the V2 equals 0. The V1 is what you got before for V2. The displacement is 2.0 meters for stopping. Here again, we're going to find the acceleration is question mark by the chapter 2 and 3 formulas. And then after that, then you can simply use net force equals ma to find the net force, and that should be successful for you. How about number 79? Oh, this important one where the force is multiple forces. So first of all, there is a lift force. So this force that you see on the left is the lift force, and we don't know what that is. But gravity is opposing it. You'll have to include that as one of the forces for the net force. The result of that is this part right here is the leftover force when you combine them all. That's called the net force for F equals ma. So when you do that for the net force equals ma, well, then you're ready at that point to say the lift force, let's call that one F sub L, okay, the lift force, minus gravity, because it's opposing it. Even though we're adding them, we're subtracting because it's opposing it, equals ma. And so the lift force, like the rocket force that we talked about, is equal to the sum of mg plus ma. That should help you on that question. 82. Hint. Convert the kilometers per hour to meters per second first. The rest of it will fall into place nicely. 92. Again, if you have multiple forces, you need to draw all the force vectors. There's a forward force of 40 newtons. And so it doesn't matter that we don't know what the frictional force is. We need to draw that so we know how we add and subtract things. So in this case, the net force that I wrote in red is the combination of the forward and the backward forces. So by net force equals ma, the net force is going to be the sum of all the forces. So that would be the 40 newtons forward minus the unknown friction force. So that's what the net force is. However, we already know that net force equals ma. So since we know that net force equals ma, why not eliminate this and substitute that for the net force? That should work successfully. So try that. Part B, the force of friction equals mu times the normal force. Remember, this is the coefficient of friction. But the normal force is just the force of something pushing back up to not be crushed. The normal force on a level is always normal force equals mg, the same as the force of gravity. The final hint I would like to give you is number 97. There is a tension formula that we will have from the notes, and that's T equals mg over sine theta. I derived that assuming that theta would always be measured with, so the important thing is to always measure the angle with the horizontal. So instead of using the 30 they give, use 60 degrees. Again, that will fall in place nicely. See ya.